Hello friends, welcome to the Neural Maze. So in today's video I bring you another open source course of more than 2 hours in which I will teach you how to build a WhatsApp AI agent. This course is structured, is divided in 6 lessons where you will learn how to build complex LangGraph workflows, how to create memory systems for agents, how to build audio and image processing pipelines, and of course, how to connect multimodal agents to WhatsApp. But before I begin, I want to introduce you to my friend Jesús Copado, another content creator here in YouTube with an amazing channel that of course you have available in the video description, so go check it out. This project has been a collaboration between the two of us, so I will let him introduce himself. So whenever you want, Jesús, go ahead.
Hey guys, I just want to say that I hope you enjoy this project, that you get a lot of value, because Miguel and I, we both have put a lot of effort and we think that we have built a system that is very modular and you can get a lot of things from it. And just maybe like to introduce myself briefly, I'm Jesús Copado. I've been coding for more than 10 years and I have a double master's in autonomous systems, so in artificial intelligence. And I myself, I also have a YouTube channel in which I also, like Miguel, explain and just get into end projects. And also I explore the world of generative AI applied to creativity, so that is to image generation and also video generation, because I'm also a cinema fan, and I think very, very soon we are going to see a lot of applications of AI applied to cinema and the visual art.
Thanks for the introduction, Jesús. So back to you. If you're ready, let's begin. Alright, so let's begin with the course structure. So we have divided this course into 6 different lessons. Lesson 1 is going to be just a simple project overview, the different services and technologies we are going to use and how they are combined together to build AVA. Then in lesson 2, we are going to talk about AVA's brain. This is a metaphorical way of putting it. We're just going to implement the LangGraph workflow. I'm going to explain to you all the nodes that we are going to implement, also the edges, the state of the graph that we need to persist, etc. So that's for lesson 2. In lesson 3, we are unlocking AVA's memories. That is, I'm going to explain the 2 different systems that we are going to enable for AVA, a long-term memory system and a short-term memory system. That's for lesson 3. Lesson 4, we are just giving AVA a voice. This is self-explanatory. By voice, we mean 2 things: creating a pipeline that allows AVA to generate its own audio notes, and at the same time to enable AVA to process the audio notes that you and I are going to send to her. Okay? Then in lesson 5, we are going to cover the vision part of AVA, the vision module, that is the capabilities to process incoming images, like if I take a picture of myself, and also to generate images about the context of AVA. So AVA is going to be able to generate images, and I will show you how to do it. And lastly, in lesson 6, it's when AVA installs WhatsApp. All right, I'm just going to show you how to create a meta app, how to attach to the meta app WhatsApp as a product, and how to connect the WhatsApp bot with your LangGraph application that is going to be hosted inside a fast API application. All right, but let's go first of all to the repo, because this is an open source project, and as such we have enabled and we have prepared all the code and all the lessons to be free, 100% free, and also in an open source fashion. So you have all the code available, and also you have videos by Jesús Copado, and also Substack articles by myself, written by myself. So let's go to the repo. I put here a link, but I have already opened a web browser for that. Okay, so AVA WhatsApp agent course. By the way, just before I forget, this is under the neural maze organization, so just go to a neural maze under repositories, and the name is very self-explanatory. Seems it's taking a little longer. ABA WhatsApp agent course, so it's very easy to find. And here you will see that apart from the beautiful diagram that Jesús and I have built, we're very proud of this diagram. You have a table of contents with a course overview, but this is something that I'm going to cover in this video, so I'm not going to read through this. Also, a very quick introduction, a demo of what you can expect, like looking at my shirt and sending an image of myself, and expected ABA to generate some comment about my image, and after that, just send in some audio note. Okay, this is something that I will show you how to do in this video. After that, you'll have a course syllabus, and this is very interesting, very important, because in here you have both the written lessons and also the video lessons. If you go to the written lesson column, you will see hyperlinks to the different articles written in Substack, in my Substack. Okay, so for example, this is the first one, Meet ABA, the WhatsApp agent. And in this Substack article, I'm just going to explain the building parts, the building blocks of ABA infrastructure. Okay? And same goes with the videos, because if you click here, you will see Jesús Copado videos. All right? So feel free to go through the course syllabus and start exploring the different lessons. Today's video is going to be a bit different because I'm just going to give you a comprehensive look of all the course, just getting into the code when it's necessary and explaining different parts that maybe we overlooked in the current course. But yeah, it's basically the same. I can assure you that if you take this video, you take the six lesson videos done by Jesús and also my written lessons, you will be a ninja in creating WhatsApp agents. All right, so now that you know a little bit about the repo, I just want to get you started into this course. And to do so, before you begin all the written lessons and before we begin the explanation that I bring you today, there are a few things you need to do. And I'm referring, as I say here, virtual environment creation, dependency installments, etc. There are a lot of stuff that it's not fancy, but fortunately I have created some guide here, this getting started guide, that covers everything you need to install before starting the course. Okay, so I encourage you to follow the steps that I'm going to do right now in real time to have everything installed in your local machine, because after that it will be much easier for you to follow everything that I'm going to cover. Okay, you can just replicate all the actions that I'm going to do and also to check and verify the code that I'm going to show. So let's get into it. First of all, clone the repository. This is pretty easy, right? But it's important. So let's create a new in desktop ABA YouTube course, for example, and cd desktop ABA YouTube course. That seems like a good name. Inside we are going to, I think I just copy it. Yeah, this is perfect. So we are just cloning the repository, and after that we are inside ABA WhatsApp agent course. Okay, perfect. So yeah, everything looks fantastic. After that, we need to install the project dependencies, and to do this I'm using UV as Python package manager. All right, so first of all we are going to create a virtual environment. This is necessary, of course, so let's create the virtual environment. It's going to use Python 3.12.8. And now look, if an UV tells us what to do, we are going to activate the virtual environment. You can see it's activated because right here it says that you're using the .vm environment. Perfect. And after that we're just going to install all the dependencies. All right, so let me see what's happening. Let's copy this again. All right, and now this is going to install LangGraph, this is going to install the Qdrant client, Grok clients, etc. Everything that we need for ABA to work. So let's wait for a couple of seconds, and now we have everything installed. So it is time to run a last command, which is just going to check that everything works well and you have the Python version expected. And this command should output something like this, so Python 3.12.8. So everything is working perfect. Now, after that, before we are getting into the environment variable creation, just going to open the virtual, the IDE. I mean, I'm using Cursor, but use VS Code or whatever you feel comfortable with. And inside, you will see that there's a .env example. And this file contains all the different API keys that you will need the project to work. Right now, and I know this, I haven't explained to you yet why we need all of this. Why do we need 11 labs or Together AI? That's something that I'm going to explain a few minutes later. But right now, the only thing that I want you to do is to run this code, run this project locally, and have a first interaction with Ava using a chainlit interface, okay? Because that will mean that everything works locally and you can proceed with the next lessons, okay? With lesson 1, lesson 2, etc. That's what I'm going to do in future sections of this video. All right, so to generate each one of these API keys, I mean, I have already done that myself, but you just need to go to here to the Getting Started Markdown. Of course, now that we have opened the IDE, you can also do it inside your favorite IDE. You just need to go to Docs and get it started. And here you just need to follow the, let me close this one. You just need to follow this section, the section about environment variables. So first of all, just copy the env example. Sorry for that. You just need to copy the env example, and then you just need to fill each one of the environment variables in here, all right? And I've also detailed how to generate the API keys for each one of the services. Like for example, here is for Grok. You need to follow these instructions and then generate the API keys and copy the API keys right here. Same for Together AI, Qdrant, etc., etc. So I think if you follow this doc, it's almost impossible that this is not working. All right, so I'm just going to create my own. I'm just going to create my environment, my .env file, and after that, I will resume the video because I just want to show you how Ava looks like. So let me create, first of all, okay, this env file. And yeah, as I was saying, I'm just going to fill each one of these variables, and I'll come back to you after that. All right, so see you in a bit. Okay, so if you're ready, let's proceed to the first run. Once you have everything set up and you have all the environment variables set in the .env file, it's time to make this first run of Ava to check that everything is working as expected. So let's open a terminal and let's run this makefile that I've created to simplify all the process, Ava run. So now a Docker Compose application is going to be created, and it contains 3 services. It's this one right here. So we have 3 services, all right? We have the WhatsApp service, the Qdrant service, and the chainlit service. So the chainlit service is just the chainlit interface that we are going to use right now in this quick demo. The Qdrant service is just a Qdrant vector database that it's used when Ava needs to remember something like a long-term memory system, all right? Don't worry, don't bother about this because we are going to cover this in detail in lesson 3. And then we have the WhatsApp service. This is a fast API application that is going to expose an endpoint that is going to be used by the Meta app when it sends the messages, the message events that it's receiving from your mobile phone, basically, okay? That's something that don't bother as well because we are going to cover in detail how to implement this WhatsApp endpoint in lesson 6, in the last lesson of this course, all right? So let's get into Chainlit then. So let's click this URL and we are inside Chainlit. So the first message will take some time because Ava needs to download an embedding model. This is something that you'll see why that's needed in lesson 3. But it has to download the sentence transformer model to generate the embeddings for the memories that it's going to extract. But yeah, no bother about it, but it will take some time. So, hello, Ava, I'm recording a video. So let's send this image, this message, and right now, if we go back to here, to the Docker desktop, if we get into Chainlit, you should see, here it is. So we are downloading a model here. Can you see it? We are downloading the sentence transformer model, and that's the reason why the first message is going to take some time. So, but we already have a response, so no way, what's the video about? And by the way, I didn't catch your name. What is it? It's Miguel. Thanks for asking. Okay, so you can see that Ava is already working in my local machine. It's not WhatsApp, I know that, but that's something that we are going to cover in lesson 6. But it's pretty cool. So, for example, can you send me an audio of yourself? I wanna hear your voice. The agent, Ava, it's multimodal, so you can ask, okay, yeah, beautiful, that's beautiful. I mean, it's sending audio notes. You can also send audio notes like, you have a very beautiful voice. In fact, I'm recording a video for my friends here in the Neural Maze channel. Can you say hello to them? And let's stop this. Oops. That's it. Okay, so we are sending this image. So hey, Neural Maze crew, what's up? Nice to meet you all, even if it's just a quick hello. And yeah, sure, we can wrap this up. It was fun chatting with you, Miguel, though. Okay, so you can see that, and we can also share, like, for example, an image. Let's, for example, take this one from my desktop. This is me. Just a very influencer-like image, to be honest. I'm really proud of this one. Love the headphones, Miguel. You look like you are in the zone. What kind of tunes are you listening to? All right, so you see the point. I mean, it's able to generate images. Oh yeah, and let me show you the last of the features. So, can you show me with an image what you're doing right now? This is also really cool because it's going to use Together AI, the Flux models, to generate also images, but that's something we are going to see in the project overview. Okay, kind of in the middle of something that's cool, but just geeking about some coding stuff. Okay, the image is a bit weird, to be honest. That's a weird image, Ava. But you get the point. Didn't mean to freak you out. Okay, so this is basically how Ava is going to work, all right? Now I'm going to just show you how to proceed from now on, all right? So now I want to keep going with lesson 1. Remember, this is the first lesson that you could see also in the repo. You have the Substack article, and you also have Jesús video. And this is something that it's going to be the same for all the lessons, so I'm not going to repeat that. For each one of the lessons, you have a Substack article, a written lesson, and a video lesson from Jesús. Okay? Nice. So, lesson 1, the project overview. Before I get into each one of these modules, which I think can be a bit overwhelming, I'm just going to explain why do we need all the services that we are using, all the technologies, okay? So I'm going to begin with Grok. Why do we need to use Grok? So we are using Grok in Ava as our LLM provider. That means that we are using Grok for text generation, Llama 3.3 70 billion. This is the model that we are going to use. Image understanding with Llama 3.2 vision, the 90 billion parameters model. And for the STT module, Whisper. We're using Whisper to transcribe when you are sending some audio note. Right. Qdrant. Qdrant, this is something that I have already said in this video, but it's used for Ava's long-term memory. That is, when Ava has to fetch some relevant information, or retrieve, let's put it that way, some relevant information from the memory, it's going to retrieve that information from a vector database, in this case, Qdrant. Right, 11 Labs. So 11 Labs It's one of the best technologies out there, probably for voice generation, for AI voice generation, and we are using 11 Labs for the TTS module, the text-to-speech module. It provides a voice to Ava, and you can tune the voice. Remember that in the .env variable, in the .env file, you had a voice ID that you could set. Basically, you can change Ava's voice, even create your own custom voice, whatever you want. Together AI, so this is necessary for the image generation module, and we will use Flux models for this, and I will show you how to do it in lesson 5. Finally, LangGraph. LangGraph is the framework that we are using to define Ava's brain, and the LangGraph workflow will connect to the different modules. So it will be able to connect to the text nodes, to the audio nodes, to the vision nodes, etc. And that's something that we are going to cover in the next lesson, in lesson 2. Okay, so now that you understand the different technologies that are involved in Ava, and also why do we need them, I think it's time to review again this diagram, because right now I think we can make much more sense out of it. So let's begin with the message that you are sending here, okay? This WhatsApp message. This is the interface. This is the interface that Ava has to expose itself to the world. It can be WhatsApp, as it is this case, because it's the fancy one, but another interface is the Chainlit interface that we have just used a few minutes ago. So if you go to the code again, all the interfaces inside source, you go to the AI companion, and let me here, that's it, let's close this, are inside this interfaces module, and we have the Chainlit interface and the WhatsApp interface. All right, as for the Chainlit interface, we have different functions and events on the different types of input. This is on the start, and we are just defining the thread ID for LangGraph, so I'm going to explain this in next lesson. But yeah, when we receive a message, how is it going to behave? How is it going to behave when we receive an audio? How to chunk the input audio? How to process and how to generate the response audio and send it back using Chainlit, etc. We have all of this defined in this interface, okay? The app.py interface for Chainlit. And the same goes for WhatsApp, although for WhatsApp it's a bit different, all right? Because we have two modules inside. One is the webhook endpoint. This is the fast API application. As you can see, it's extremely simple. It's just a router, and we are just calling this WhatsApp response, all right? That's right here. And the WhatsApp response is analogous to Chainlit. It just defines how the WhatsApp bot is going to respond to different incoming messages. If it's a message, if it's an image, if it's an audio node, etc. And depending on that, it's going to call different services or modules. Like for example, if it's an audio, it's going to call Whisper to transcribe the audio. If it's a message, it's going to just call the LangGraph application. And if it's an image, it's just going to call Llama 3.2 Vision to provide a transcription, not a transcription, sorry, like a detailed description of the incoming image. All right, perfect. So now you understand the different interfaces that Ava exposes to the user. After that, after we have sent our message using the Chainlit interface or our text phone, it's time to convert this message, this multimodal message, because it might be an image, an audio, or text, into plain text that we can input to the LangGraph application, all right? So here we have three options. First option, on the left. The input message is an audio. In this case, we need to call Whisper to transcribe that audio. And this is something that you can check under Ava modules. If you go to modules, you will see that there are different kind of modules, image-related modules, memory modules, schedules, and finally speech. If you go to speech, you can see that there's a module called speech-to-text, and it contains basically a class to handle speech-to-text conversion using Grok's Whisper model, which is exactly what we need. you receive an audio and it's transcribed and converted into text that you can now send to the LangGraph application and to the Grok model. Okay, that's going to generate a response. All right, here we have this async function for transcribing, that it's taking the audio, etc., etc. All right. More information about all of this is in Jesús' videos, and I will also cover this in more detail in lesson, I think it is 4 of this course, okay, about all the audio module capabilities. All right, let's get back to the diagram. So now we have another option. The income message is an image. In this case, we need a way to describe the image and to transform this image into a textual representation. And to do this, we just need to go to modules, image, and image to text. That is going to implement a class that handles image to text conversion using Grok's vision capabilities. In this case, we are using Llama 3.2 vision with 90 billion parameters. By the way, it's amazing that Grok provides this model for free because they are very powerful models. And yeah, exactly the same. We are following the same structure to keep the code clean. We are defining this analyze method, this asynchronous analyze image method that is going to take the income image data that we're going to read from here and just generating and transforming the image into base64, sending the encoded image into the Grok server, and returning a description that we are going to send to the LangGraph application afterwards. All right, so yeah, this is it, image to text. Let's go back to the diagram. The third option is the trivial one. If we are inputting text, just a text message, then of course this is going to just be transparent. We're just going to take that text message and just get the text message into the LangGraph application. All right, perfect. So now that we have processed the income message, it is time to understand how this LangGraph workflow works. So LangGraph is like the brain of ABA, right? And as it is a very important module for ABA, we have created its own Python package, which is in here, the graph folder. All right. If you click inside the graph folder, you will see that there are a lot of modules defined for this LangGraph application. You have the state. This is very, very important for any LangGraph application because you need to define the state of your graph, right? We have the nodes, all the different nodes that we are going to implement for ABA, the image node, if you want to generate an image, audio node, if ABA decides to generate an audio, the router node, when ABA decides the different output that it's going to generate, different content. We also have a definition of the graph that in this diagram is called the LangGraph graph builder. This is something that we are defining here, taking all the nodes and edges and specifying the connections between all of them, all right, and also defining the state. Okay, and this is it. And yeah, also utils, where we're defining chains, helpers, etc. All right, you can see, for example, here. This summary that you see here, this rectangle, it's interesting because you might have very long conversations with ABA, right? So the problem with this is that if you keep appending all the different messages to the chat history, it will be a moment when the system breaks because there are too many languages in there and you will spend, of course, a lot of tokens. That's the reason why we also need this summarization logic that is implemented by one of the nodes. All right, so if you go here, I think it's at the bottom. Yeah, it's the summarize conversation node that is going to just provide summarizations of the conversation so far. All right, perfect. LangGraph is in connection with a lot of different modules. Okay, for example, it's in connection to this that maybe you are interested, like this fetch current activity. This is like an activity planner because Jesús and I thought that it would be really interesting to bring or to give ABA realism in the sense that if you speak to ABA at 7 a.m., she should be, I don't know, preparing breakfast and grabbing a cup of coffee. But if you speak to her at 9 p.m., she should be cooking dinner and reading a book before going to bed. You know what I mean? So that's the reason behind, the reason behind this fetch current activity section that you see here. And also, if you go to the code, you can go to modules, and inside schedules, you have this context generation schedule that contains all the different schedules for the week and also for each hour of the day. In fact, if you go to schedules here, you will see that we have schedules for each one of the day, like from 6 to 7. Ava starts her day with a morning run along the Embarcadero, taking in the San Francisco Bay views while planning blah blah blah. From 7 to 8:30, gets ready to work, reviewing the latest ML papers on Grok's competitor, etc. All right, so realistic, realistic scenarios for an allegedly ML engineer in Grok, because Ava allegedly is just that. Okay, so that's why we wanted to create this module. Okay, another important part is the memory section, and you have one here, the long-term, and also here the short-term memory. The short-term memory database, it's something pretty straightforward because we are just using built-in functions from LangGraph. In fact, if you go to the interface, let me close this, to the interface to Chainlit, you will see that we are importing this LangGraph checkpoint SQLite AIO async SQLite saver. This is basically the short-term memory. All right, we are just storing the graph in a synchronous manner into SQLite, and that's it basically. I mean, let's check where this is used, but yeah, for example, here we are using a call, an asynchronous call with streaming fashion to this graph, to the LangGraph workflow, and we are using the async SQLite saver to define the state, the way that we are storing the state. Okay. And that's something that we need for the short-term memory, all right? Because otherwise, the state, I mean, it will be a graph without state, which means that we wouldn't have even a chat history, all right? Perfect. And now we go to the other fancy part of memory, which is the long-term memory DB. This is the most beautiful thing of Ava, I believe, because it allows the system to remember you even if months have passed since your last interaction. All right, so we thought it would be really nice to implement this, and you have the code for this inside memory, modules memory, and you have here this memory manager that is going to interact with Qdrant in both ways. First of all, it's going to store all the relevant facts that you have manifested in the conversation, like for example, I'm Spanish, or for example, I work for a UK company. All of this is going to be taken and is going to be stored as relevant information from the user into a vector database, in this case Qdrant. And also it's going to be fetched whenever Ava needs to retrieve some relevant information for us. Like for example, do you remember what I work? Or hey, I'm just going to go to the city where my company resides. And she will be like, okay, it's in UK. You get the point, right? Like this long-term memory implementation or system. This is very beautiful because we will be able to see in lesson 3 how memories are represented as vectors using Qdrant Cloud. Okay, that's going to be really, really cool. All right, and last but not least, we have these 3 modules in here, the 11 Labs, Grok, and Together AI. 11 Labs, it's necessary when Ava decides to produce an audio node, and you have all the code related to that into speech, text to speech. And inside you see that we are importing all the client for 11 Labs, and we are defining a text to speech class that handles the text to speech conversion using 11 Labs models, right? This is going to be called using the synthesize async function. And the same goes for the Together AI calls, all right? You need to go to the image and text to image. And this is exactly what we saw previously, that I was asking Ava for an image that was pretty weird, okay? So that's basically what we are going to ask here, like handle text to image generation using Together AI. And Ava is going to use the previous conversation and also its current activity to generate a very cool image about it. And I think that right now, given the time that it is here in Spain, she's probably working in some quantum computing inspired algorithms for ML. So I think that's the reason behind the image that she sent, like very weird quantum entanglement stuff, all right? So yeah, but this is the text to image. And lastly, we have the Llama 3.3 that I put it here in a different rectangle, but that's basically the LLM that by default is going to be called whenever we need a text response. And that's defined inside graph, utils, chains, and this here, yeah, get character response chain, that's it. And inside, you see that we are calling this helper method, get chat model. And yeah, if we go to the settings, to the Pydantic settings, you will see that we are using Llama 3.3 70 billion versatile, okay? And this is it. I think this is a very profound introduction to AVA. In the next lessons, we will cover LangGraph, how to implement, how AVA LangGraph workflow is implemented, the different nodes, different edges, etc. We also cover the memory, etc., etc. But yeah, hope you like this module, and I'll see you in the next module. Okay, so welcome to module 2. In this module or lesson, we are going to cover AVA's brain. That is the LangGraph workflow that we hinted in the previous lesson. Today, we are going to do a deep dive into the system. Okay, so you can see here a very simplified description or overview diagram of the LangGraph workflow that we are going to implement today. Let's see here the cool logo, LangGraph. So this is going to start, the workflow is going to start with this node, the memory extraction node. This node is going to be connected to Qdrant to extract relevant info for the conversation that is going to be stored as a memory inside the vector database, inside Qdrant, okay? Then we have this router node. The router node is the one that has to decide on the type of response that AVA is going to deliver. A text response, an audio response, or an image response. All right, so this is the node that's going to take care of that. It's just an LLM that's going to evaluate all the conversation so far, and it's going to say, okay, it makes sense to send a text message, or okay, it makes sense to send an audio note. All right, you get the point. So that's the router node, and the information is going to be stored inside the state graph, all right? The graph that I'm going to show you later. Of course, both the router node and the subsequent nodes have to be attached to the graph state, and we are going to store that inside SQLite. This is something that we are going to explore in more detail in next lesson, in lesson 3, but it's important because that's the place where the state of the graph is going to be persisted, all right, in this SQLite database. And also, today I'm going to show you the activity planner, that scheduler that's going to select, it's going to decide the activity that AVA is going to be currently doing, all right, these AVA activities. And we are going to inject that by means of an inject context node. Perfect. After that, we are just going to select the workflow that is given the information that we have from the router node. We're just going to select the workflow, audio, text, or image. If it's audio, we go through this branch. If it's text, here. And if it's an image, through the image node. And inside the audio node, we are going to use 11 Labs. In the text node, we are going to use Llama 3.3. And in the image node, we are going to use Together AI. Everything is going to be controlled by a class, as I showed you in the previous video. All right. And after that, of course, the audio node is going to generate an audio. The text node is going to generate text, and the image node is going to generate, as you can see here, an image. And that's basically what we are going to append to the last node. This is a node that is accessed by a conditional edge. That is, sometimes it will be accessed, and this node is called the summarize conversation node, and it's going to summarize the conversation so far. It's just another chain, another LLM call that is going to summarize the conversation to reduce the size of the chat history. All right, and after that, that's it. We are just returning the message to the user. All right, so let me put welcome here. Perfect. So now I just want to show you how it looks, not with this diagram, but with LangGraph Studio, because this is a tool that is really cool to use, really useful, to be honest, if you want to simply check how the LangGraph workflow looks like. So we are going to move into LangGraph Studio, and here you can see that I have my graph already imported. You just need to open LangGraph Studio in Ava the WhatsApp agent course in that folder, in the folder of the repo, basically, and it will open this this interesting graph for you. Okay, so as you can see, we have, let me see if I can explode it. Yeah, this is fine. We start with this start node. This is typical in LangGraph. You just have to define both the start of the workflow and the end of the workflow in here. Okay. And then we start with the memory extraction node, as we already said. If you go to the code, you will see all the graph implementation inside the graph folder. And if you go to the nodes, you will see that here we have this memory injection, sorry, not inception. Inception is a movie. This context injection node, all right? Oh, sorry, no, not this one. Is the memory injection node, sorry for that. We have this memory injection node and also this memory extraction node, all right? So we are going to start with the memory extraction node. That is the node that is going to extract the relevant information from the conversation with the user, right? And this memory extraction node is just going to access the get memory manager. Remember that this get memory manager was defined inside modules memory, all right? This memory manager. And we are going to extract and store the memories using this method of the memory manager class, all right? This extract and store memories. We are extracting the memories from the conversation, and we are storing the memories as embeddings using the sentence transformer as embeddings inside Qdrant. All right, that's it. Perfect. So now, if you go back and we open the graph module, this is the place where we are defining all the different nodes and the edges and the connection between nodes and edges, right? So first of all, we are going to define the state graph, all right? This is something that you always need to define when creating a LangGraph workflow. You need to create the graph with a state, and in this case, we are importing this AI companion state. So let's check this because it's really important. So the AI companion state is all the information that we are going to store in Ava's graph state, okay? State class for the AI companion workflow or Ava workflow. It stands the message state to track conversation history and maintains the last message received. And the thing about this is that you won't see the message property in here because this is something inherited from the message state. But at all times, we are going to keep a property, keep an attribute containing the list of all the messages. And that's something that we need to provide messages or responses with meaning, right? Because otherwise it will be like from scratch conversation over and over, right? So yeah, this is the AI companion state. Apart from the messages, we also have the summary, that is the summary of the conversation. We are going to store that into the AI companion state. Also the workflow, which workflow we need to follow, audio, text, or conversation, image, or audio. This is the current workflow, the AI companion is in. Then we have the audio buffer to be used for speech to text conversion. So imagine that Ava decides to generate an audio, right? Using the audio node. That's something that we are going to look right now. In that case, we need to store that audio at some place. And we are doing that by encoding, by keeping this audio buffer inside the state using a bytes type. All right. Then we have the image path in case Ava is generating some image for us, like the one we saw at the beginning of the video. This is going to be stored in your local drive, or if you are deploying to the cloud in in a cloud file system, but we need the path, all right? We need the path so that Chainlit or WhatsApp is able to get that path and render that image in your chat interface. Then we have the current activity of AVA based on the schedule, remember, of the activity planner. Apply activity, this is something deprecated, that's not something that you need to bother about. And finally, the memory context. The memory context is the context of the memories to be injected into the character card. All right, and this is basically all the things injected by the memory injection node. All right, this is basically what we are using in there. All right, okay, but just to follow again the graph. So remember that we were starting with the memory structure node, and then we are getting into the router node. All right, so the router node, that it's right here, it's just going to get a chain, use one of our predefined chains. You can check in here. And this chain is just going to use a router prompt that is able to decide between the different workflows that we need to follow, right? The workflows that we are going to select are conversation, image, or audio, all right? And we are just generating a string, selecting each one of the workflows, right? Perfect. So this is basically what the router node is going to do. And if we go back to the graph implementation, you will see that we are also defining this router node and also, of course, the memory structure node. But here we want to see how we defined this node, the router node. All right. Okay, so now let's go back to LangGraph Studio, and in here you can see that the next node is the context injection node. That is the node that is going to inject all the activities that AVA is currently doing from the activity planner. As we did before, you can go here to the nodes.py where we define all the nodes, and inside you can see that the context injection node is going to call the schedule context generator. It's going to get the current activity, and then it's going to apply this activity because it can be true or false, and it's going to put the activity that AVA is currently interacting with inside the current activity attribute. All right, that you can see right here, this current activity. Remember that this is one of the attributes that we had in the state, in the graph state, both the apply activity and also the current activity. Okay, so if you go to the graph, you will see that, of course, we are also defining the node for the context injection node and importing the context injection node implementation. And now let's move into the memory injection node. As you can expect, is the next graph here. And the memory injection node is, let's go here, it's just reading all the memories, all the information from Qdrant. So it's just that. I mean, we are just using the get memory manager again. Remember that this class is going to take care of both writing and reading from Qdrant. And after that, we just take in all the relevant memories from Qdrant, converting that memories, these vectors, these embeddings into text, and just put in all of this information, all of these relevant memories into the system prompt of AVA. That, by the way, you can check here. Inside prompts, you can go to the character card prompt here, and you have all the AVA's personality, a background, also the user background, and that's where we are going to put this memory context, all the information retrieved from Qdrant, the current activity. This is the place where we are going to inject the current activity from the previous node, and also different rules for behavioral rules, you know, like always mention that you are an AI, never mention, sorry, that you are an AI or a virtual assistant, always start the conversation by asking the username, blah, blah, blah. A lot of different rules that you can define here. But the important thing that I want you to notice is that we are passing both the memory context and the current activity to the system prompt. And these two placeholders are going to fill up with the information provided by the two nodes, by the memory the context injection node, sorry, and the memory injection node. All right. So after these two nodes are applied, we will have a complete character card prompt. Perfect. So now it's time for to take a decision, to make a choice, because right now Ava has to decide between three nodes: the conversation node, the image node, and the audio node. Okay, and let's see the implementation very quick of each one of them. So we have the conversation node here. It also has to take into consideration the current activity. Okay, we need to also take into consideration for the response what Ava is currently doing. Then we are getting the memory context because this is something what we also need for the response. And we are using this chain, the get character response chain. I'm going to show you here, but it's very easy. We just get the chat model. In this case, it's llama 3.3 70 billion. Remember, we are using a system prompt, the character card prompt, and we are creating this chat prompt template with the system message, and as message placeholder, the messages that we are passing, remember, inside the graph state, even if we are not explicitly defining it. But remember that the message attribute was inherited by the messages state class. Okay. Perfect. So after that, we are just generating this this chain. By the way, there's a fancy custom removal parser here, a string output parser that inherits from this LangChain class, and just remove asterisks because sometimes with these role-playing models, the LLM is going to generate some actions, some metadata commentators and stuff like that, and we wanted to get rid of all of that, and that's the reason why we created this asterisk removal parser. Okay, but that's basically it. All right, so that's the chain that we are going to use for the conversation node, and after that we are just creating, calling the invoke, the asynchronous invoke with the messages, just taking the messages from the graph state, current activity, and the memory context. And we are passing this config because we needed to access all the state persisted into SQLite. Okay, this is something that we are going to see in the next lesson, how we are letting LangGraph persist and read the state from SQLite, but just to let you know that this config means basically that. And we are returning this AI message with the content, the response of Ava, and this is going to be appended into our chat history. All right. Same goes for the image node. In this case, it's a bit different because, well, we also need the current activity, the memory context, etc., and we also need a response, like a textual response. But apart from that, we also need to create some image-related content. So first of all, we are defining the getTextToImage module, the class that we, well, let me show it to you in case you don't remember, but the text-to-image class, okay, that I show you in lesson 1. And this text-to-image class is going to generate the image that Ava is going to return to us, all right? So first of all, we need to create a scenario. This is necessary for Ava to define the context in which she's going to generate the image. And then we are just generating the image, given the scenario image prompt, the image prompt of the scenario that's going to be generated, and an output image path. That's the place where Ava, well, not Ava, the LangGraph workflow is going to store the image, all right? Okay, and after that, we are just calling the chain with messages, current activity, and memory context, because, of course, apart from the image that we are going to generate, we also need some textual response that we can append to the chat history, all right? And lastly, the audio node. And the audio node is basically the same as before, but as you can expect, instead of the text-to-image class, we are going to import the text-to-speech class that we have here, this text-to-speech. And yeah, we are just, again, calling the invoke, chain, and we are passing the messages, the current activity, and the memory context, because apart from the audio buffer that we are going to store, remember in the graph, in the state, as here, audio buffer, we also need a textual response. And that's what we are going to achieve by calling the conversational chain again. All right, so that's for everything for the 3 nodes that we are going to select. And of course, we are defining the 3 nodes in the workflow in this function. So conversation node, image node, and audio node, and that's it. If we go back to LangGraph Studio, you will see that there's a last node here apart from the end node. That's the summarize conversation node, and we've been talking about this node for a while. So let's go to the implementation. The summarize conversation node is going to take care of reducing the length of the chat history. Remember that if we have long conversations with Ava, then it might be the case that we end up with too many messages in the chat history, and it will cost us a lot of tokens. I mean, if we were paying, in case of Grok, it's free, but of course you will end up with no tokens left. And of course it will be exponentially slow, okay? So this summarize conversation node is going to use an LLM, a simple LLM call to reduce the size by generating a summary of the conversation so far. Okay, so here you have both messages in case there is a previous summary. If there is a previous summary, then this is the system prompt that it's going to use. So this is summary of the conversation to date between Ava and the user, and you put here the summary so far. Extend the summary by taking into account the new messages above. All right, so this is in case there was already a summary. If it's the first time that the summarization node is called, then this is the new prompt. Create a summary of the conversation above between Ava and the user. The summary must be a short description of the conversation so far, but that captures all the relevant information shared between Ava and the user. All right, so after that, we are defining the messages like this. We are taking all the chat history from LangGraph state, and then we are defining this human message that is just passing this instruction to the model as a human message. All right, and then we are generating the response. Perfect. This response is the summary. So as the return dict of this node, we are going to pass response content as the summary property. And for the messages, we are not passing additional messages, but we are using the remove message class to define messages that are going to be deleted from the chat history list. Okay, in this case, we are deleting everything until total message after summary. So we are deleting everything until 5 messages before the summary. Okay, that's basically it. All right, and then we of course return these delete messages as the messages, and LangGraph internally will take care of deleting all the irrelevant messages. Okay, since we have the summary condensating all the knowledge, all the information. All right, so that's everything for the nodes. We are just defining here the summarize conversation node. And now we need to define the flow. That is all the edges that you see here, all these tiny arrows connecting the different nodes. That is something that we need to define. By the way, here you can see normal edges with solid lines, but you can also see here these dotted arrows, all right? And that means a conditional edge. That is edges that can be or cannot be activated between the connection between the different nodes. And this is something that we are going to define inside the define the flow section. So first of all, we are going to add an edge between start and the memory extraction node. So that's something pretty trivial, right? Start the memory extraction node. Then we are going to define another deterministic edge between the memory extraction node and the router node. This in red right here. Then we are defining 2 more edges, one that connects the router node and the context injection node, and the context injection node and the memory injection node, okay? And this and this, okay? Pretty straightforward. And now we start with the conditional edges, and this is the interesting part, because the first conditional edge that we are going to define is going to connect the memory injection node with 3 different nodes. Remember, the conversation node, the image node, and the audio node. And the thing is that we can define that by creating a function inside the edges module that is going to basically do that. Select the workflow. We are going to take the workflow property from the state graph. Remember that we were defining this property inside the router node, okay? And now we are just going to return the name of the node to which this node, the memory injection node, has to be connected, okay? So if it's an image node, then this conditional edge is going to return the select workflow function that is going to be triggered in the conditional edge. Is going to say, okay, image, and in this case, this connection will be activated, okay? And the same goes for the rest of them. I think it's pretty self-explanatory. All right, so that's for the first conditional edge, the router edge. And now we are going to define three more conditional edges that are going to connect the conversation node, the image node, and the audio node to the summarized conversation node, okay? Remember that the summarization it's only triggered if the length of the messages in the chat history is more than a specific quantity. You can go to our settings, to the Pydantic settings, to see exactly how many messages trigger the summarization. In this case, we put 20, but if you want longer conversations, you feel free to change all of these configurations. Of course, didn't say that before, but if you want to change the model from Grok, or you want, you can change whatever you want in this project. But yeah, the should summarize conversation function that is called from the conditional edge is going to check for this. The length of the messages stored in the state graph, the chat history, has to be less than the total messages summary trigger. If that's not the case, then the summarization is going to be triggered. And the next node is going to be the summarized conversation node. Otherwise, it's going to go directly to the end. Perfect. And lastly, we need to connect the summarized conversation node to the end, because otherwise it will never stop, right? So if one of these nodes are connected to the summarized conversation node, and we don't connect the summarized conversation node to the end, LangGraph will raise an error because there's no logical end to the workflow, right? Perfect. So now we understand the workflow, the LangGraph workflow. So now when we were doing some, let me open again Chainlit. When we were doing these funny experiments with Ava, you can truly understand what is happening. Let's do it again and rephrase what's happening under the hood. So if I write the first message like, hello, Ava, first of all, this is just going to track for any relevant information about me. Okay, so I'm playing soccer. I'm going to play paddle. Play paddle this evening. That's true, by the way. So first of all, this is going to be activated, right? So right now, Ava is going to know, okay, this guy plays paddle, and I bet he's pretty bad at it. Then the router node is going to detect, okay, does it make sense to generate any kind of image or audio for this? No. Text. So the router node is going to say, okay, the workflow that you need to follow is the conversation workflow, right? After that, it's just going to inject all the relevant information about me, like for example, his name is Miguel, or he studied physics, or whatever, okay? In this case, it's not even relevant, to be honest. And then it's just going to generate the conversation node, because as we said, the workflow, the router node is going to say conversation. So conversation node and end. The conversation is just 4 messages long, so the summarization is not going to be triggered, all right? But what happens if I say, can I hear your voice? In this case, the same process will happen, but the router node is going to say, okay, he's asking for something related with audio, so let's change the workflow. In this case, it's going to be audio. And when we arrive here, it's going to go through this path, all right? And then just going to end. So yeah, we have here this, and also remember that apart from the audio, we also have this text that Ava is going to respond, because we wanted to attach to its audio some textual response, okay? And finally, just to try the 3 workflows, so let's ask, what are you doing? First of all, this should inject, I mean, all of them, all of the responses are going to inject. Let me check 1 second. Oh, this is cool. I really like this. I didn't know she loved ramen, to be honest. So Ava sometimes even surprises the creator, you know? So just go back to work, trying to wrap up this ML project. It's cool because she assumed that it was okay to send another audio node, which I think it's quite right. But now let's ask about ramen. So can you send me, oops, can you send me a picture of that spot? I'm interested. And right now, the workflow that should be activated is just the image workflow, right? So it's going to generate an image, and it's just going to send, hopefully, a picture of this ramen spot. Oh yeah, this is beautiful, beautiful, beautiful. Okay, so yeah, seems to be interesting. I mean, beautiful. Yeah, I like it. Perfect. So that's everything for this module, guys. I think this covers everything, or almost everything, for lesson 2 for the graph, for LangGraph. In next lesson, we'll cover Ava's memories. We will finally understand how to use SQLite to store the LangGraph state, and also how to use Qdrant to store all the memories. Of course, this is something that we have already seen, like the nodes that are going to interact. But in the next lesson, I just want to show you the memories and how they are represented inside the vector database, okay? But that's it. I hope you enjoyed this lesson, and I'll see you in lesson 3. Bye-bye. All right, so let's begin lesson 3, Ava's memories. This is not something new. I've been talking about the different kind of memories in the 2 lessons that we have covered, but I just want to mention it again because I think it won't hurt you. We have one short-term memory, this one right here, and we have one long-term memory, all right? The short-term memory is basically a way to store the LangGraph state, and the long-term memory is a way to store memories, relevant facts about the conversation of Ava, between Ava and the user, right? Let's follow this workflow because I think it's pretty self-explanatory. So suppose we are having a conversation like the one we had in the previous lessons using Chainlit, right? So Ava starts by saying, hello, I'm Ava, and then I respond, right? Hey, I'm Miguel, nice to meet you. Then Ava responds back, where are you from? And I say, I'm Spanish. Then I live in San Francisco, work here as a machine learning engineer. And no way, I'm also a machine learning engineer. What a coincidence, right? Then what? Really? Yes, I'm developing a project called Ava with Jesús Copado. So this is the flow, this is the sequence of messages that both Ava and I are interchanging, right? All of these messages are going to be appended into the messages list. Remember that this is something that we saw in the state, in the graph state. There was a parameter, a message attribute, and that's where all the different messages were going to be appended, like a list, basically. Then we also have, SQLite, we have all the different properties that are contained into the graph. You can see here that these are all the properties that we defined in lesson 2. In fact, let's go back to the graph, to state, and you can see here the summary, the workflow, audio buffer, image path, current activity, memory context, all of them things that you have here defined, right? So this is a representation, like an artistic representation of how LangGraph state is going to be stored into SQLite, all right? And this is the important thing. Here we have the list, the sequence of all the different messages that both Eva and I have been exchanging, right? Okay, so this is pretty straightforward, it's very simple, and you will see that we only need one call, one simple import from LangGraph, because all of this SQLite interaction is just a built-in function in LangGraph. So it's pretty easy. It's really easy to implement. But now, about Qdrant, remember that we saw some nodes, in particular 2 of them, that were related to the Qdrant, both extraction and injection, right? These nodes, in particular this memory extraction node, had the responsibility of extracting relevant information from the conversation between the user and Eva, and storing this information into the vector database. And then this memory injection node was going just to retrieve the relevant information for the chat. Okay, that's something that we saw in previous lesson. But today I just want to show you the memory manager in more detail. This is something that we also covered here, and there's like another visual interpretation of how this long-term memory is going to work. And I just want to mention, just to be 100% sure that you are understanding how it works. So you can see here that when I say, hey, I'm Miguel, nice to meet you, Eva is going to extract some relevant information like Miguel. And this information is going to be stored as an embedding, as a vector inside the vector database. After that, when I say, I'm Spanish, you, the same is going to happen. Eva is just going to take the relevant information that Miguel is Spanish, and it's going to store this into the vector database. And the same goes to machine learning engineer, because the fact that I'm a machine learning engineer says to be relevant for Eva, so she's going to take that information and to store it as a memory or as a vector embedding. And finally, the same with my friend Jesús Copado and I, who are the creators of Eva, and that's something that Eva finds relevant. Okay, perfect. So now, oops, this is lesson 4. I don't want to make any spoilers. So now that we understand this, it's time to go to the code again, and we are going to explore in a bit more detail what we mean by this context, not the context manager, sorry, the memory manager, right? So if we go to the nodes, to the graph, sorry, and we go into the memory injection node, no, even better, the memory extraction node, I think is better. We can see here that we are importing the get memory manager. That's something that we saw in lesson 2, and we are just using this memory manager class to deal with all the Qdrant interaction. So now let's explore in more detail this memory manager class. Remember that this was stored into the modules, memory long-term, and inside memory long-term you can go to vector memory manager. And also we have this vector store. Okay, so we are not going to get into much more detail about this vector store, just to let you know that it's a wrapper around the Qdrant client in Qdrant abstractions like distance, point extract, vector params, etc. And what we are doing is define a data class and also the class vector store, which is a class to handle vectors, vector storage operations using Qdrant. Okay, so that's basically what we are going to find here. Create collections, if a collection already exists, find similar memory, store memory. So we are just creating a thin layer of instructions around Qdrant, basically. So what I want you to understand is this memory manager module that contains, let's see the different imports in this module. So first of all, we are going to import some kind of prompt, right? This is the memory analysis prompt. This is how we are telling the LLM that it needs to extract actual facts or relevant information from the conversation. And you have it in the prompts module, where we also have the router prompt, we also have the character prompt, etc. We have already seen some prompts in this module. So yeah, you have it here, right? And we have also some few-shot prompting so that the LLM knows what we are expecting from this information extraction, right? Perfect. So after first of all, we are importing this memory analysis prompt. We are also importing the vector store, this get vector store that we defined here, and the vector store module. Remember that we were just in the module that we were extracting away, and we were creating this wrapper around Qdrant. And then we start with this memory manager. Well, not to forget that we are also defining this memory analysis pydantic model that we need to structure the output, right, from the LLM. Here we are defining this chat grok, and we are just defining a structure output. The output is going to provide two params, two fields. First of all, if is important, whether the message is important enough to be stored as a memory, that's an important one. And the formatted memory, that is basically the memory after a formatting has been executed in front of them, right? All right, so this is the memory manager, the manager class for handling long-term memory operations, right? So we define the vector store as attributes, also the LLM, etc. And the important methods are the ones for extracting and storing memories, and also for getting relevant memories, right? This extract and store memories is the method that we are going to use when the memory extraction node is going to be run, right? And extracts important information from a message and stores in the vector store, right? So we are just going to analyze the message content, and after that we are going to get if it's important. Remember that we had this in the pydantic model. As we are structuring the output, then we have a field that contains if the information is important or if it is not, right? So if it's important and analysis formatted memory, this is a formatted memory, then we are just going to check if similar memory exists. If there is a similar memory, then we are not going to do anything. We're just going to skip this step. If there is no similar memory stored in Qdrant about this, like suppose I continually tell my name to Ava, or maybe I tell her that I'm going to paddle. That's something that I always do on Tuesdays and Thursdays, so it makes no sense to store over and over again the same information, right? Okay, so in case this information is no in Qdrant, which means that it's a new memory for Ava, then we are storing this memory. And we are going to use the vector store abstraction, the class that we defined in the vector store module, right? This one right here. And then we are just storing the memory, the formatted memory, and after that, just adding the ID to identify the memory inside Qdrant and a timestamp, okay? The same goes for the other method, the get relevant memories. Remember that we had another node in here, the memory injection node, that's going to take to retrieve the similar content to the content that's being chatted between Ava and the user, right? So that's basically what we are going to do to this with this get relevant memories, retrieve relevant memories based on the current context, right? And we're just going to use again the same class, the vector store class that we defined in the other module, and we are searching for memories. We are passing the context, and we are defining the top k vectors that we want to fetch, which I don't remember exactly what we put here. Yeah, 3. So we are going to fetch 3 relevant memories from Qdrant, right? And then we are just going to put everything into text, because otherwise we wouldn't be able to adapt and to attach all of this information to the prompt. All right, and that's basically it. I mean, that's everything for the memory manager, for the long-term class. Just before I forget, I want to show you what it looks like in LangGraph, where when you want to attach some short-term memory, when you want to store the state. Remember that that's what we are doing here in this left rectangle. Let me show you how easy it is in LangGraph to do this. So if we go to the interfaces and you go to Chainlit, for example, you will see that we are importing this LangGraph checkpoint, SQLite, AIO, sync, SQLite saber. This is the class that you need to use when you want to store the state of the LangGraph workflow inside SQLite, all right? And the only thing that you need to do is whenever you're going to call the graph, before you compile it and you make the invocation, you just need to call this async SQLite saver. So in my case, I'm just creating a SQLite database that is going to be located when I run it locally, of course, inside this short-term memory folder. You see here that there is a memory.db. That's a SQLite database that contains everything, and it's referenced by the Docker Compose application that we deployed at the beginning of this course, of this video. So yeah, the only thing that we are doing is just telling the async SQLite saver from constring to read the information of where this database is located. In this case, you can go to the Pydantic settings and simply see that it's already here to app data memory database, because remember that we are running this from inside Docker Compose application, right? Oops, yeah. And that's basically it. I mean, we just need to run this, define it as the short-term memory, and we are passing this short-term memory as a checkpointer, all right? When we compile our graph, we're just passing the short-term memory as the checkpointer, and that's basically it. I mean, as simple as that. So whenever we are compiling the graph and generating a response, LangGraph is going to store the result. It's going to persist the LangGraph state when everything is done inside SQLite. And whenever we are going to, whenever we compile and generate another response, it's going to previously read all the information stored into disk, into the memory.db that we have right here. It's just going to read the state and to use this state to compute the next state. Okay, so that's basically it. It's just a way to persist, to checkpoint the state of a LangGraph workflow. That's basically it. That's our short-term memory. So you can see how trivial this is. But yeah, this is everything for this lesson. Last thing that I wanted to show you is now that we have the Docker Compose application running, I just want to show you something. Let's minimize this. If you go to localhost 6333 dashboard, like this, you should be able to see Qdrant vector database. Okay, remember that at the beginning I told you that you needed to create Qdrant Cloud. Okay, that makes sense if you want to deploy everything into Google Cloud Run, because it's going to be connected to Qdrant Cloud. When we are running everything locally with the Docker Compose application, there's a local version of Qdrant. Okay, in fact, let me show you the Docker Compose application again. So if you go here to the containers, you will see that we have Chainlit, WhatsApp, and also the Qdrant application. That's the one that I'm showing you right now. All right, inside the collections that you have available in Qdrant, you have this long-term memory. And if you get inside, you can see that there are 12 points, that is 12 memories. If you get inside, you'll see that there is, like ask if they could hear my voice. Okay, different memories inside. So I will show you how it looks like in this visualization. It's sad because for this tutorial, for this course, I reset everything, I deleted everything and started from scratch. So all the memories are gone. But if you have a lot of conversations with Abba, it's very cool because you will have, I don't know, 1,500 different memory points here. And it's really, really funny to see how memories are represented here in this TTS and STT, I think it is, the algorithm. Yeah, it's very funny to see how all the memories are represented in 2D, in this vector representation. But yeah, here you can see things like, okay, it's Miguel, it's recording a video. Yes, it's here, the text. Or, I don't know, recording a video for friends in the Neural Maze channel, and is going to play paddle this evening. Okay, so you can see now how this is working. It's just extracting relevant info, my name, I play paddle, I'm recording a video for the Neural Maze friends, you guys. That's basically what is happening. It's just taking this information, converting this information into embeddings with a sentence transformer. That's something that I didn't cover, but just to let you know, it's a pretty common embedding model. And we are transforming each one of these memories, it's one of these pieces of text, into embeddings and storing the embeddings as points in Qdrant, right? And that's it. By the way, the length, I didn't mention this, but the length is 384. So this is it. This is how the memory for ABA works. In the next lesson, we will cover how to give ABA a voice, which I think is really interesting, and we will be using for this E-level labs. All right. So yeah, I'll see you in the next lesson. Bye bye. So let's begin lesson 4, giving ABA a voice. This lesson is going to be focused on the voice pipelines from ABA. So as we did in previous lessons, we are going to start by understanding this first diagram, where I'm putting everything in a visual and I hope a simple way, so that you can understand in a high overview how this system is behaving, and then we can move into the code. So everything starts in this first element when I send an audio note. You can see my photo here, and I'm sending an audio note using WhatsApp saying, do you know the neural maze? This audio note is going to be processed by WhatsApp or by Chainlit, doesn't matter, and then we are going to send this audio buffer into Whisper. We're going to use Whisper to transcribe our audio, and it's going to be transcribed into text. You can see here in 3 that we are transcribing the audio into text, and we are sending the text into the already known LangGraph workflow, LangGraph graph that we are using as ABA's brain. After that, we are going to provide a response using the conversational chain with Llama 3.3 70 billion. Remember that this was part of a node when we were generating this conversation, this output, this response to the user input. And after that, the response is going to be passed to E-level labs again. And in E-level labs, we are going to take the text and we are going to generate an audio. Then this audio buffer is going to be passed away to WhatsApp, and we are going to receive this in our mobile phone, or if we are using the Chainlit interface as we did previously, we are going to receive a voice note using Chainlit. But that's basically it. It's a very simple pipeline in which we are going to take an audio, use STT and STT system, speech to text. We are transforming that audio into text. We are generating a textual response using LangGraph, and after that we are applying the TTS module, that is E-level labs, to generate a new audio and present the audio to the user, return this audio to the user. Let's move into the next slide. As I mentioned in the previous slide, we are using Whisper as the STT module, all right, as the speech to text module. Whisper is one of OpenAI models, but we are going to use the implementation that Grok did of this model. It's completely free and it's really fast. So we are going to use Grok's Whisper to transcribe the audio that we're sending to ABA. Okay, so now let's move. Let's put the tablet here. Let's move into the code again. And as you remember, if we go to modules and speech, you will see that we have 2 modules here, speech to text and text to speech. So first of all, we are going to investigate speech to text. This is the place, this is the class that's going to handle speech to text. And it's going to do that using Grok's Whisper model. The only method that you need to pay attention to is this transcribe method, all right? This contains everything, all the logic necessary to take an audio and to generate text out of that audio. And we are using, of course, the client, this Grok client. We import from here, from here. We are just using the Grok client, and we are going to generate, this is it. We are going to call the API, the audio transcriptions create method from the API, and we are just passing the audio file, as I said before, that we are using this audio buffer. Then we are selecting the model, Whisper Large V3 Turbo. The language is English and the response format is text. So we are generating text. And after that, we are just returning the transcription. Okay, and where in all of this code base are we calling this class? That happens in the interface, both in WhatsApp or in Chainlit. So if we go to the interfaces, let's go to Chainlit, for example, you will see that we have several methods that take care of dealing with the audio, right? So for example, here, this is the method that is going to take each one of the chunks that we were describing previously, okay, these chunks. And then when the audio has finally been processed, the audio is complete, what is going to happen here is that we are going to transcribe the audio data, all right? You can see here that we are calling exactly the method that I have just described to you. We are using the speech-to-text class and we are just transcribing the data. And then this transcription is the text that we are going to pass to the LangGraph workflow as we defined here. I mean, this is exactly what's happening here. We are transcribing the audio with Whisper. That's happening here. And then we are passing this transcription into the LangGraph workflow. And that's what's happening in this block right here, right? We are just calling the short-term memory, etc. But you can see here that the messages that we are passing a human message, and inside we have the transcription. Okay, so I think this is pretty clear. I mean, the STT pipeline is really easy to understand. And now let's move into the TTS pipeline, because here is where we have to use 11 Labs. And I mean, I guess you all know 11 Labs is one of the best frameworks, of the best applications out there for AI voices. And what we are going to do is just to call one of the voices that 11 Labs already provides, or maybe if you want, you can also create a custom voice and just use that on your code base. Okay, I don't know if you recall, but when we began this course, I told you that you needed to set some environment variables, and one of them was 11 Labs API key, and the other one was 11 Labs voice ID. So if we go to 11 Labs, so let's take this out, you will see that there are a lot of different voices inside. Okay, if you want to take, like for example, Rachel, if you want to take one of these voices, you just need to click on the voice that you want and just copy the ID right here at the bottom. Okay, and now having the ID, you just need to go here and paste the ID. But this is something that I have already explained in the getting started section, so you can refer to that. But yeah, I just wanted to make it clear. Okay, so once we have the 11 Labs API key established and also the 11 Labs voice ID, this is something that of course you can change. And if you want to create custom voices, I recommend you to check out Jesús' video about it, because he is explaining how to create this custom stuff. In this case, I'm going to omit all of this because I don't think it's relevant for my video. I'm just going to show you how we are going to interact with this STT, this TTS, it's confusing sometimes, this TTS pipeline. So we are going to get into the speech, the modules of speech, remember that, and inside we are just going to get into the text-to-speech, into the TTS. And here you have another class very similar to the STT class, to the speech-to-text, but in this case we are going to call another method. It's called the synthesize. That's going to convert text to speech using 11 Labs. It's pretty straightforward. So what's happening inside? So what is happening is that we are going to use another client. In the case of Whisper, we were using the Grow client. In this case, we are going to use 11 Labs client, all right? And we are just taking the text that we want to synthesize. This is something that we are going to get, remember, from LangGraph. Let's go here again, and let's go here, yeah. So at this specific point in this arrow, we are sending the text to 11 Labs. And inside, we are just going to generate, to synthesize an audio, a voice out of this text. So we are passing the text that we generated and then a voice. And the attributes that you need to pass to this voice, basically the 11 Labs voice ID and some voice settings like the stability and similarity boost, etc. This is something that you can tweak. And finally, the TTS model name. In this case, we are using 11 Flash V2 5, but this is moving so fast that probably by the time that I'm recording this video, you'll have even a better model to use. So feel free to change that, because I guess that as time goes by, we will see better and better AVAs out there. Okay, so after that, we are just transforming this audio generator, generating the bytes, and we are storing that bytes inside the graph state. Okay, remember that if we go to the graph and the state, remember that we were storing as bytes the generated audios by AVA. Okay, and yeah, there was something else that I wanted to tell you, and it's about how we are accessing, how LangGraph is going to access this TTS module. And this is going to be accessed from the audio node, okay? From here, the audio node. So if we go to graph to the nodes again, we go to the audio node, you will see that we are getting the text-to-speech module. That is the module that we have just described, the class for 11 Labs. And what we are doing is just to, first of all, generate a response, okay? This is basically what's happening here. We are generating a response, and then we are taking this response and passing this response to the text-to-speech module. So that's exactly what's happening right here. We're taking the response from the conversational chain, Llama 3.3, and we are taking the response and passing it to the text-to-speech module. And after that, we are just taking the output audio, the bytes, and we are putting these bytes inside the audio buffer property from the state, and also returning the response as an additional message. And this message, of course, is going to be an AI message from LangChain. Okay, and that's it. That's everything for the audio. I hope you have enjoyed this lesson. I told you it was going to be easy. It's pretty straightforward. The next lesson, we are just going to cover AVA learning to C. So see you in the next lesson. Okay, so let's begin lesson 5, AVA learns to C. This is the last pipeline that we are going to build, the vision pipeline, and after that, lesson 6, we are just going to cover how to connect AVA with WhatsApp. Okay, so this is the last one, but I think you're going to enjoy it as well. So as we always do, let's explore this diagram. So today is going to be about vision, and everything starts with an image of myself playing golf. This is a new hobby that I have, and I started playing a few weeks ago. So yeah, this is a picture of myself playing this beautiful sport and sending an image about myself and also a caption saying, "Out golfing this morning. You?" Okay, so this is number 1, and what's going to happen is that the image is going to be sent into Llama 3.2 90 VLM parameters in Grok. Okay, and this is going to generate a description out of the image. For example, in this case, it's a bit comical, but a guy in white totally struggling at golf. Okay, so this is the description that AVA is going to attach, or not to attach. This is the description by which AVA is going to represent my image, okay, the textual description. After that, we are going to take this description and this message, my message, and we are going to input that into the LangGraph workflow, as always, into AVA's brain, to continue with the metaphor. After that, we are going to call the scenario generator. This is going to be used by the Llama 3.3 70 billion. Remember that we already talked about the scenario generator when I was showing you the different classes in AVA's modules, but we are going to see that today as well. And yeah, we are also attaching the AVA activities, the activity planner, and the memory modules, both the short term and the long term. And after that, what AVA is going to create is a scenario prompt. Okay, that's exactly what you can see here at 4. This is what's going to define the scenario or the prompt that we are going to send to Together AI, to the Flux models. All right. So this is basically a prompt that's going to be sent into Together AI, into this image generator that's going to create this beautiful image. And at the same time, we are also going to send the same chat history into Grok, into Llama 3.3 to generate a text response. In this case, building an LLM from scratch while devouring a ramen. What you will receive in WhatsApp is just this image, this ramen image with this caption, building an LLM from scratch while devouring ramen. So let's continue with the slides. Just wanted to mention that for the image description, we are going to use Llama 3.2 Vision, okay, the 90 billion parameters. This is also available in Grok, so you can use it for free. And this Llama 3.2 is a type of one type of models called VLMs, the visual language models. If you want to know more about these kind of models, you can go to Jesús Copado video for this lesson, for lesson 5, because he has an amazing introduction to VLMs, how VLMs and multimodal LLMs are different, etc. So I encourage you to go to that video because it's amazing. But yeah, just to summarize, for the image description, we are just using Llama 3.2, which is a type of VLM, of visual language model. And for the image generation part, we are using Flux, the Flux models that are available, the Flux family of models, to be exact, to be precise, which are available from Together AI. Okay, in fact, if you go to your Together AI account that you have probably already created, if you follow the Getting Started Markdown, you have this Together AI, this front end, and if you go to Playgrounds, you can start playing with different models. Okay, so we are going to use this Flux 1 dev, and here you can see like generate an image of a cat playing basketball, I don't know, whatever you want, and this is exactly the model that we are going to use, and the image is beautiful. And this is the model that we are going to use, that in consequence, this is the model that Ava is going to use under the hood when we generate images. It is important that, remember, if we go to the slides again, do you remember this scenario generator and this scenario right here? So that's basically what we are going to generate to send to Together AI, okay? This generate an image of a cat playing basketball. This is exactly what we are going to create automatically in this scenario generator. All right, the code is going to create a scenario that makes sense given Ava's activities, the memories, and all the context surrounding the conversation with you. All right, so that's basically what we are going to do with this number 4. All right, so let's get into code. So first of all, as always, remember that we have all these different modules inside the modules folder. And in this case, we are going to open the last of the folders, the image folders. We are going to start with the image to text. That, remember, is the first thing that we need to do when I send an image to Ava. As always, we are following the same format for each one of the classes that you will see here under the modules folder. We are defining, in this case, an image to text class. The method that you need to pay attention to is this analyze image, that is going to analyze an image using Grok's vision capabilities. Remember that we are using Llama 3.2 90 billion vision, the VLM that is needed to generate descriptions out of an image. Okay, and as the parameters, of course, we need to pass the file path or the binary image data in bytes, and also the prompt, an optional prompt to guide the image analysis if we want. Okay, this is not mandatory. And then what we are going to do is, using this image, we are just encoding the image and sending this image using the Grok API call. Okay, the Grok API, we are making a call with the chat completions create using the image to text model, this ITT model name that is Llama 3.2. We are passing the messages, which is a role user. The text is the prompt if we are providing any help prompt to this to guide all the generation. And as the image URL, we are just passing where the image is generated. In this case, you can see that we are passing this base64, so we just we don't need to pass any specific, any normal URL. We're just passing the base64 image that we created here, encoding the image bytes. Okay. All right. So then, when we generate the response, which is text, we are just returning it to LangGraph. Basically, this is going to be accessed from LangGraph as always. Okay. So where is this class going to be called? As you can expect, it's going to be called from the interfaces. The same happened for the audio classes, so I guess this is not surprising to you guys. So if we go, for example, to Chainlit application, you will see that when we receive a message, this onMessage callback, you can see that if the element that we are receiving is an image, then we are going to read this image as an image bytes. And after that, what we are doing is just to image to text, analyze image. And this is just going to generate the description, all right? After that, we are just appending the description to this content placeholder that contains the image analysis. And this is exactly what we are going to pass to LangGraph. Okay. You can see, by the way, how we are passing this information here. Okay, this human message, we are just taking the content, and the content is just the placeholder with all the information from the description generated by Llama 3.2, by the class that we have just defined. All right, so that's everything for the image to text pipeline or the image to text workflow. Now let's move into the text to image, which I think is much more interesting. So this is also going to happen in its own class. So text to image, have a class as always. And here you have two different Pydantic models. One for the scenario prompt that is defining two fields, the narrative and the image prompt. Narrative is basically the AI's narrative response to the question, and the image prompt is the visual prompt to generate an image representing the scene. Okay, so there are two different things. And then we have this enhanced prompt, because after we create the prompt, there's going to be an additional step in which we are going to enhance it. Okay, but I don't want to spend too much time in this, so let's go straight into the important methods. So the text to image is of course going to define together AI client, and then we have this generate image here. All right, this is the method that is going to take care of generating an image from a given prompt. Okay, so it's going to receive as parameter the prompt and also the output path. The output path is the path that we are going to use to store the image. So given the prompt, what this method is going to do is just to call the together client and the generate API call, and it's going to pass the prompt, the TTI model name. Remember that we are using Black Forest Labs Flux 1 Schnell free, the Flux models. TTI means text to image. And yeah, the width, the height of the different settings and parameters of the output image that's going to be generated, the number of steps in the diffusion process, and the response format, which is going to be formatted as a base 64 JSON. Then we just need to decode this image, and after that we are just writing the image into the output path. Okay, so by the end of this method you will have the image stored, persisted into disk. And what about this create scenario method? This method is going to create a first-person narrative scenario and corresponding image prompt based on chat history. So that's exactly what I was telling you about at the beginning. We need this scenario generator because Flux models are expecting a prompt for generating the images. and we need to generate these images, this prompt, sorry, by its own method. And that's exactly what the create scenario method is going to do. All right, we are just creating the scenario from the chat history, and you can see that it's also done by a chain. Okay, so we are defining here the chat croc LLM, the chat model from LangChain. Then we are structuring the output with the scenario prompt that we define at the beginning. Okay, so it's going to return two different fields, the narrative and the image prompt. After that, we are just creating the proper chain with the prompt template, input variables, chat history, template, image scenario prompt. And let me show you this image scenario prompt, because here we're just telling the LLM how this prompt to be sent to Together AI needs to be created. So engaging first-person scenario based on the recent conversation context. Imagine you are an AI with the ability to experience and visualize scenes. Provide both a narrative response and a detailed visual prompt for image generation. And here, a bunch of, well, the recent conversations, the chat history that we need to pass, and also brief objective, like create a brief, engaging first-person narrative response, and generate a detailed visual prompt that captures the scene you are describing. And then some examples, okay? Perfect. We have defined the chain. It's time to invoke it with the chat history. And here we are just generating the scenario, and we are returning the scenario. And now let's check the last of the methods, the enhance prompt, because remember that after we have generated the scenario prompt, we need another trial, another call to enhance this prompt, to make it better, because after this method called the create scenario, after this chain has been invoked, we detected, we noticed that sometimes the prompt scenario wasn't as good as we expected, and that's the reason why we created this enhance prompt, to enhance a simple prompt with additional details and context, okay, to make it even better for Together AI generation, for the Flux model generation, I mean. And it's basically the same. I mean, you're just creating the chat model, we are structuring the output. In this case, it's with the enhanced prompt we defined here at the beginning. All right, it just has one field, this content field. And yeah, we are defining the chain. And lastly, well, let me check here. Yeah, let me show you, because in this case, it's not going to be the same prompt. Of course, we have the image scenario prompt, but this is going to use the image enhancement prompt. That's going to enhance the given prompt using the best prompt engineering techniques, such as providing context, specifying style, medium, lighting, etc. Okay, so we are just taking the raw prompt that was generated by the image scenario prompt chain, and what we are going to do is just to enhance this prompt. All right, applying prompt engineering techniques. It's really cool because it's like some kind of meta prompting, if you think about it, because we are telling DLLM how to refine a prompt with good prompting techniques by trying to implement ourselves good prompting techniques for the enhancement prompt. So I'm just trying to mess up with your head a little bit, but think about it, because there's some kind of self-reference here. Okay, so after that, yeah, we are just defining the chain and invoking the chain as always to create this enhanced prompt. And this enhanced prompt at the end of the day is the one that we are going to pass to generate image. Okay, so where is this class going to be called? Okay, so let's go to LangGraph Studio, and remember that this class is going to be called from the image node. So if we go to the image node here, into nodes and image node, you will see that we are getting the text to image module. That is the text to image class. And after that, we are just going to create a scenario and then generate the image out of the scenario, okay, with the image prompt. Perfect. Then we are just attaching the scenario message using a human message from LangChain, where we are just putting the image prompt. And after that, we are just updating the messages, okay, of the LangGraph state. We are just taking the current messages with state messages, and after that we are just adding these scenario messages, okay, which we are telling, yeah, image attached by ABBA, generated from prompt, blah blah blah. After that we are just generating the response, the textual response, using the chain, the conversational chains. Remember that we were importing and we were instantiating this chain here with the get character response chain, and as the output, as the response of this node, we are just returning an AI message with a textual response, and apart from that, the image path that we defined here, okay? Remember that in the state of the graph we had, here we have this image path attribute that we could use to store the image path. All right, and that's basically it. I mean, if we go to the interfaces, for example, to Chainlit, you will see that if the image return is, if the message returned is an image, in this case, if the output state values get workflow is an image, then we are just going to get the message content. This is the caption that we are going to attach to the image sent to the user by ABBA. And then we are just taking this, using this chainlit.image class to take the image path from the output state, from the graph state, and display inline basically, okay? And here we are just sending back a message containing the response and as elements an image. That's basically what we are going to do in Chainlit. I'm not showing how to do this in WhatsApp because that's for the next lesson, which we are going to cover shortly after this, because this lesson is finally over. Lesson 5 is over. Hope you have enjoyed this vision pipeline. I'll see you in lesson 6, which is, by the way, the last lesson of this course. See you there. Okay, so here we are in lesson 6. Ava installs WhatsApp, the last lesson of this course. So very close to the end of this video. In this lesson, the last lesson, we are just going to cover the most important part of the video probably, because this video is about a WhatsApp agent. And in this lesson, we are going to cover exactly that, how to connect Ava with WhatsApp. Here in the diagram, you have a very specific implementation, a very specific overview of how Meta apps and the WhatsApp product is going to interact with Ava, right? So suppose I'm sending a message using my mobile phone, WhatsApp in my mobile phone. What's going to happen is that this message is going to arrive at the WhatsApp webhook, and WhatsApp, that's by the way assigned or attached to a Meta app. That's something that we're going to cover at the end of this module. But this message is going to arrive at the WhatsApp webhook, which is going to send the message back to a callback, okay? A callback that we need to define in this WhatsApp webhook. A callback is just a URL that we are going to use, or that WhatsApp is going to use to send the events, in this case, the message events that are arriving to the application, to the Meta application. Okay, so that's basically what we are doing here. We are just going to send the message events to a callback defined with this callback information. The information is just the URL, okay? The information encoded in the callback makes reference to a very specific endpoint. In this case, I'm focusing on Google Cloud Run, but I will show you also how to deploy this instead of Cloud Run in your local laptop using ngrok to expose your local fast API with HTTPS to the web. So you need to be careful, but that's another way to do this, okay? And here inside Cloud Run or using ngrok, you're going to expose to Meta your LangGraph workflow, your LangGraph application, the one that we have been covering since lesson 1, okay? And yeah, here you have the Grok LLMs, Together AI, Level Labs, and Qdrant. Okay, so the different modules that we have been covering. But now I want to talk to you about the two different options that you have to deploy or to make WhatsApp, to make the callback available to WhatsApp. Option 1, ngrok. So you're probably aware of ngrok, you probably know the service, but what we are going to do with ngrok is to expose the fast API application that we have actually running in the Docker Compose application. Remember that we were exposing this fast API application containing all the code for WhatsApp, okay? All this code, this was the endpoint properly. Let's make reference to this WhatsApp router, okay, that we define inside the WhatsApp response module. Here in this WhatsApp response module, we are defining 3 modules that we are going to use in the different functions: the speech to text module, the text to speech module, and the image to text module, because the rest of the modules are going to be accessed from inside the different nodes in LangGraph, right? And this is the endpoint that we are going to put in the callback information. If we go back to the live representation, remember that we needed some callback information in the WhatsApp webhook. So that's exactly what we are going to put in there. You're going to put the URL, the HTTPS URL that ngrok is going to provide to us, or maybe the URL of the Google Cloud Run service that you're going to deploy. But yeah, just all that URL, and at the end, this WhatsApp response endpoint. That's the one that we are going to use. 2 methods are get and post, and this WhatsApp handler is the entry point of everything that's going to be sent by the Meta application. This get method is necessary to verify that the Meta app is actually the application that tries to access our LangGraph workflow, all right? And that's the reason why we need this WhatsApp verify token. This is something that we are going to see later in the Meta application, okay? But if it's not a get request, then we are going to enter into the post request workflow. And here, the first thing that's going to happen is that we are going to get the content of the request. If there are messages inside the request, we're going to check for the type of the messages, okay? If it's audio, image, or something else that is text, right? If it's audio, we're going to call a helper function. This is the process audio message that you have here. And this process audio message, oops, I think I'm lost. Oh no, here. This process audio message is just going to take the audio that we have sent, and it's going to transform this audio into text. That's basically, remember that what we did in Chainlit with Whisper, that's exactly what's happening here. We're just calling the speech to text module inside the process audio helper function, and we're just generating text out of audio, okay? The voice note that you have just sent using your mobile phone is going to be transformed into content, which is just a string, okay? A string of text. Okay, after that, there's another if clause. What happens if the message is just an image? In that case, we are going to take the image as bytes, and then we are going to analyze the image. Remember that to do that, we are just using the image to text. That is calling Llama 3.2 90 billion, the VLM, the Vision Language Model. Okay, and then we are adding that as the content like this. And finally, if the content is just text, then we are just getting the text and the body of the message, and that's basically it. After that, we're just calling the LangGraph application, the LangGraph workflow, doing the asynchronous invoke, and we are passing the content. We don't care if it's of audio type, of image type, of text type, because all of them are going to be transformed into text. And that's exactly what we are going to send to our LangGraph application. And after that, we are just returning the output state, okay? The state of the graph after everything, after the graph has been invoked. Then we are going to select the workflow. This is necessary because we need to know what type of content Ava has responded with. Audio, is it image, is it text? So, and also we need the response message. That's basically the message that Ava has responded. And it coincides with the last message in the messages chat history, right? Perfect. So after that, we are just checking for the content of the workflow. If it's an audio, then we are taking the audio buffer that we know for sure that's going to be populated with bytes class that contains the audio buffer, the audio that Ava has generated. And then we are just sending the response with this method that I'm going to show you, but it's basically in here. And I don't know what's happening, but yeah, it's here. And this send response method is the one that is going to take care of interacting with the Meta application. All right, you just need to provide here all the headers with the WhatsApp token, the type of the content type, which is application JSON, and we are just going to interact with WhatsApp, okay, with the audio, with the images, depending on the type of content that you are generating. And finally, we are just making the client the post to the Meta URL, okay, this graph facebook.com, providing here your phone number ID. Remember that in the env example, we had 3 environment variables related with WhatsApp, right? So WhatsApp phone number ID, the WhatsApp token, and the WhatsApp verified token. This is something that you have detail in my Substack article about connecting an AI agent to WhatsApp. I'm going to leave you in the comments my Substack in case you want to check all the Ava series in there. And of course, you also have all the different lessons in the repository. But if you go to the Substack article regarding the 6th lesson, you will see I'm just detailing everything you need to create the Meta app, and also how to take the phone number ID, how to create the access token, how to create all the different environment variables that you need to put Ava to work, okay, to connect Ava to WhatsApp. All right, so something that I'm not going to repeat here, but just to let you know that it's very simple to create all of these 3 environment variables, and that I explain everything in much more detail in this Substack article. All right. Perfect. So as I was saying, this send response is going to take care of connecting, sending the information back to the Meta application. And then the Meta application is just going to send all the information back to our WhatsApp. Okay, so we will see all the response of Ava with an audio, with an image, or whatever. All right, so we were just here. So if it's audio, as we were saying, we are going to send the response as an audio. If it's an image, same for the image. And if it's the text, same for the text, okay? And that's basically it. That's in a nutshell what's happening here in the WhatsApp response. All right. So what we are going to do with the first option that I was telling you about, option 1, LangGraph, is to make this WhatsApp response that we have just defined in FastAPI available to the world, to the web, by creating an HTTPS URL, okay? And this is very, very easy to do. Let me create a terminal. You will see how easy this is, because you just need to, log into LangGraph and create an account. So it's very, very easy. So, but what I want to show you is how to create this HTTPS connection, because you need this URL, this HTTPS URL for WhatsApp to work. So running this, we are just creating a new HTTPS URL from our local host, and this is the callback ID that we need to use for WhatsApp to work. Okay, I will show you how to do it. Remember that, as I was telling you, I'm not going to explain in detail how all the WhatsApp stuff is going to be implemented, because you have this Substack article covering how to get the verified token and how to get the phone number ID, etc. What I will show you is how you can attach, attach this callback information to your WhatsApp product. Okay, so here you have my products in Meta Developers app, In my case, there's only ABA. I mean, there are no additional projects in here. And if you go to WhatsApp and to API, I think it's configuration, it takes a lot to process. I don't know why. Okay, you can see here that there's a callback URL. This is basically what we were showing at the beginning. This is callback information. All right, so what we need to do is to pass exactly the URL that Grok has provided, the ngrok, sorry, has provided. So now let's put this over here and let's copy the name of the endpoint. All right, so it's WhatsApp underscore response. So WhatsApp underscore response. And here, I think you can put whatever verified token you need. This is just necessary if you need it, because it enables you to detect that the messages, the connections are coming from Meta app and not from another weird place. Okay, so that's the reason why you need to put this. I mean, put whatever you want. Of course, if you are going to deploy this to proper production, I mean, do something else and try to make it really, really robust. But for this quick experiment, I mean, just put 1, 2, 3, 4, whatever to test that it works. And in fact, this is one of the environment variables that you need to put in here. All right, so yeah, this is the WhatsApp verified token. So in here, I will put something like this to try really fast that everything works. But after that, of course, create something robust. So please be sure that you are careful with that, because at the end of the day, you are exposing with ngrok, at least you are exposing your laptop to the web. So be very careful, please. All right, so after that, we are just going to verify and save. And if everything goes according to plan, we should see that, yeah, it seems to be working fine. In fact, let me show you my Docker desktop, because I just want to, oh yeah, I think it's here. If we go to WhatsApp, you will see that, okay, so warning, stack level. Yeah, here. Can you see this? The verified token. So this first get request with 200 of the request status, which means that it's okay. Means that Meta has successfully identified and verified that our ngrok endpoint works as expected. So let me get into my WhatsApp, and I'm going to change a little bit the distribution, because otherwise you will see all my contacts. So I will pause the video and I will come back to you in a second. Hey, so here I am in my WhatsApp web. I've just saved the WhatsApp phone ID that I was telling you about before. And yeah, I just renamed this phone ID with ABA, which makes sense. And now I'm just going to send the first message to this mysterious number to see what happens. So, hey, I'm recording a video and it's very late. I'm a bit tired. Haha. Yeah, let's do something like this. Okay, so let's see if ABA responds. So I think that the beginning will take some time to download the embedding model, as I told you about before. But after that, we should see something happening under the hood. So let me check. Oh yeah, here it is. So we have the first response from the WhatsApp agent. So what's the video for? And yeah, late nights can be a real killer. What's keeping you up? So I'm doing a video about a WhatsApp agent called ABA. That's a funny coincidence. I'm ABA, by the way. What's the video for a project? So yeah, okay, got it. Yeah, I want to use my phone. I want to use my microphone, so allow this. Hey, I know it's a coincidence. Basically, I've created a chatbot with one friend, with Jesús Copado, and we are basically trying this chatbot, which it turns out that it's basically you, because you, Ava, are not real. Sorry to tell you that. Let's see if she gets angry or something. This is going to be funny. Wait, what? That's a weird thing to say. I'm definitely real, lol. And by the way, it's Ava, not Eva. Okay, yeah, my English is not perfect, I know that. What makes you think I'm not real, by the way? Let me use one of my pictures. Let's see if I have something here. Yeah, for example, this one. This is a real human, not you. Okay, so we can see here, I mean, apart from all the comedic stuff, you can see here that everything is working as expected. So it's processing the audio, it's processing the images, etc. So nice pic, looks like a sick spot to chill, but what does this have to be to not be being real? Okay, I love it. I love this kind of chats. All right, so yeah, that was basically what I wanted to show you here in WhatsApp for the WhatsApp interface. Now I'm going to close this WhatsApp web, and I'm just going to show you how you can replicate everything but using Google Cloud Run. In case you don't want to expose your local laptop with ngrok, you can do exactly the same by using Google Cloud Platform, and in particular Google Cloud Run as a service. So let's go. Hello, so here we are inside Google Cloud Platform. Maybe you have never used Google Cloud before, so if you go to the repo, you can get into docs, and here there is a markdown called GCP setup that tells you how to create your Google Cloud account and also to authenticate with Google, etc. We will be using Google Cloud Run because this is a very cool service when you want to deploy containers, and that's exactly what we want to do with Ava. We want to deploy the container that takes care of all the fast API application, basically a container that's going to expose the WhatsApp response route, right? That's exactly what we did in the local host, but in this case we are just going to deploy this fast API application, but in Google Cloud Run, right? Perfect. So to do this, well, first of all, as I was saying, you need a Google Cloud Platform account. By the way, if it's your first time using Google Cloud, you will receive, I think it's around $300 for free, and this is pretty cool. I mean, Ava is pretty cheap because we are just creating one container that contains the FastAPI application, but it's going to be really cheap. You will see that. And if you're not, you are like me and you have consumed all the tokens and all the free credits, as I was saying, it's going to be really cheap. Okay, so if you go back to the docs, I'm not going to do exactly the same as before. I mean, I'm not going to deploy the Google Cloud Run and then to chat using WhatsApp. I'm just going to show you how to deploy the Google Cloud Run application, and just to give you hints on what you need to do after that to connect the same way that we connected with ngrok. Okay, but yeah, in this docs you have, first of all, how to download, how to not download, but how to log into Google Cloud, how to create your account, etc. And then how to authenticate with Google Cloud using your terminal, set the Google Cloud project. This case, in my case, for example, it's Ava WhatsApp agent. And then I'm going to start saying Ava instead of Ava, because Ava has told me, as you all witness, that it's Ava and not Eva. So yeah, let's change the name. That was kind of hard. That really upset me. Okay, so let's focus. After that, we just need to set the Google Cloud project and then add the necessary permissions. These are the permissions that you need for all the different services to be connected with Google Cloud Run, okay? Like Cloud Resource Manager, the Secret Manager, because Google Cloud Run will need to extract some secrets that contain the different services like Qdrant Cloud, the API key for Level Labs, Together AI, etc. Okay, all of this is going to be stored as secrets. This is a very good practice when you're deploying things into production, and yeah, that's the reason why we need all of these services enabled. Okay, then we are going to authenticate to Docker registry, because the first thing that we need to do is to containerize the application, create a Docker image, and push it to the Docker registry in Google. So after we have authorized all the Docker registry permissions, it's time to create the Docker repository. In this case, I created one Docker repository called Ava app, but you can change this if you want, but I think this is pretty self-explanatory, right? So we create the Docker repository, and we create secrets for Cloud Run. In particular, we are creating secrets for Grok API key, for Level Labs, in Level Labs by ID. I mean, everything we defined in the env example, okay, in the .env. I'm not going to show you my .env. Everything that we define in there is going to be recreated as a secret, okay? So that then when we deploy everything into production with Cloud Run will be able to extract the API keys from these secrets. Okay, now we are going to attach to Cloud Run permissions to read these secrets. That's something that we are creating with this gcloud command. And lastly, we are just submitting the deployment. And this is interesting because I have created one YAML here, one Cloud Build YAML in this repo. What is Cloud Build? It's a way for deployment of services in Google Cloud. So what you do is you define the different steps. It's similar to GitHub Actions, for example. Maybe you're more familiar with that. We are doing basically the same, but this is specific to Google Cloud Platform, okay? And it works really well with their services. So in this Cloud Build YAML, what we are going to do is, first of all, to build the image that I was telling you about, the ABBA image. This is basically the fast API application that we are going to expose to the Meta app. After that, we are just going to push this image into the Docker registry that we have just created using the commands before. And then we are just going to deploy a service, a Cloud Run service that is going to use the previous image, the image that we have just pushed in the previous step. All right, so now that we understand how this is going to work, I'm just going to copy, where is the docs here? Okay, just going to copy this and to submit the Cloud Build job that is going to create the Cloud Run service. Okay, so I mean Europe West 1, and just like this, we are starting to build everything into Cloud Run. Okay, this command is going to take a while. I mean, it takes a little bit because it needs to do a lot of different stuff. So I will pause the video and I'll come to you right after this is finished. All right, so the Cloud Build job has finished. You can check that if you go to the console and you get inside Cloud Build, the Cloud Build tab. You'll see the different builds here. So this is mine, the last build that I've made. And now we can go to Cloud Run and we should see, yeah, here it is, a new service, a new Cloud Run service. And if we click inside, well, this is basically ABBA, but in the Cloud Run, in the cloud version, right? So now there's one additional thing that we need to do. If you go to the security tab inside authentication, we're just going to allow unauthenticated invocations, because for this example, we just want to create this public API or website that's going to make things very easy for WhatsApp to really connect and verify this endpoint, okay? So that's basically what we are going to do. In fact, now if we open this URL, we go to docs, we should see, yeah, we should see the Swagger front end, but in this case, accessing from Qdrant, which is really cool. Now, if you want to run WhatsApp from Qdrant, using Qdrant as a callback URL, you just need to put this URL here, okay? And that's basically everything. And here, just use our silly and dumb verify token and just verify this. So now if we go to Qdrant and we go into the logs, we should see a successful GET request from the Meta application. Okay, here it is. Yeah, this is it, the verify token. So it's already working. And now if you go to WhatsApp, you could start talking with Ava again, just the same way that we did when using LangGraph for forwarding the URL, the local host, right? And that's everything, guys. This is everything for today. I know it's a long video, but I just wanted to explain in detail everything about this course. And as I was saying at the beginning of the video, you have much more resources to read and to watch. You have 6 Substack articles in my Substack blog in the Neural Maze, and you have 6 videos in Jesús YouTube channel, which is really cool, and you should definitely check that. But yeah, this is everything for today. We really hope that you enjoyed and you learn a lot through this ABA course. And yeah, just to let you know that next week I will be starting a new open source project with another content creator, and I think it's going to be really interesting. We will be covering agents again, but with a very different interface, with a video game interface. So I think it's going to be really, really interesting. So, but yeah, that's everything for today. Hope you have enjoyed. And now I really need to go to bed because it's very, very late here in Spain. So good night and happy coding.